Alright, here is one example of model selection, and this I'm just going to help you go through the text. This starts in I think 6.11, and they're looking at, or well actually I guess 6.1, they're looking at auction prices. Okay, and often what we'll do is a tilde like this in statistical things for looking at the model, and what they first look at in 6.1.1 is just price. Is that some beta times the condition plus some alpha. Okay, and condition is just a two-level categorical data, in which case 1 if new and 0 if not new. Okay, and they run through that and they get this prediction that the price, the estimated price, is going to be equal to 10.9 US dollars times that condition plus 42.87. And so it looks like it probably matters. They go through, they get the standard error here, standard error on the slope that we would have given to us as well would be 1.2583, and therefore if we divide 1.2583 into 10.9, we get a t statistic of 8.66, they say, and if we then look at the p-value, it's basically 0. At least to, they say, what, 4 decimal places. They get 0. Okay, so it definitely looks like condition matters a lot. Very small p-value, pretty good size slope. So what does 1090 mean? We need to also interpret these things. Well, it says that the average price jumps $10.90 when going from old or not new to new. So in this case, we can interpret the slope as just, well, that difference in the average when we go from the one level where we called it 0 to the new level which we called 1. Okay, but there may be some confounding variables, right? And some other possibilities could be like the photo, and in which case whether it was stock photo, okay, and they say that was a 1, and if it was unique photo, that was a 0. So we would call anything with a 0 a base case in this case. Duration, you know, how long did the auction last? And again, that's numerical, and they say it could be from 1 to 10. And then wheels, now this was a Mario Kart thing, and I don't really understand what that is myself, but wheels, and but again, it's numerical. So you see, we have some possible confounding things here. If what we're most interested in is whether it was new or old, these other things may matter, right? You know, whether the photo was possibly, you know, a stock photo is probably a good photo. You know, it's put out by the company or whatever. A unique photo is probably the photo of the actual item. Duration of the auction, I mean, it certainly seems reasonable that a longer auction may get a different price than a shorter auction. And then again, the number of wheels, I don't really understand what that is in the Mario Kart world, but I'll go with it. And now, so if we run our regression with all of these, then what we end up with is our price is all of a sudden now it's 5.13 times our condition. That's interesting. It dropped in half, that slope, plus 1.08 times the photo, plus minus 0.0, I'll call it 0.03 times the duration, and then plus 7.2852 times the whatever that wheels. All right, and so as we look at this now, and we look at those different slopes, then this says that new condition implies a jump, so I'm going to put an up arrow, of $5.13 on the average. But so you see, all of a sudden, the effect of the condition, it's only half of what it had been. Okay, why? Well, because tossed into some of those other items, or tossed into that condition may have been some of these other items, like whether it was a stock photo or a unique photo or the number of wheels and that sort of thing. And so similarly, the photo says, hey, you use a stock photo, so stock photo, that's going to get you $1.08. Longer, okay, longer auction, that implies that actually it goes down by 3 cents a day. Okay, so this is down, so I'm going to do the negative 3 cents per day, since the auction was in days. And then the wheels, that implies that, ooh, now that, see, has a bigger effect than the condition. It goes up $7 and about 29 cents, according to the textbook, per wheel. And so what used to look like, oh, condition was such a big player, you know, at $10, well, actually, when you look at the confounding variables, sure, condition matters, $5 for new versus, you know, losing that $5 for old, But actually, it's the number of wheels that really matters. I mean, wow, $7.29. Now, beyond that, if we look at the standard errors, then we also see, so I'm going to write those numbers again. So 5.13, 1.08, minus 0.03, and 7.29. The standard errors on each of those, they were 1.05, 1.06, and 0.19 and 0.5547. Well, if we look at that, then our t statistic is 4.88 when we do that division. So we're just dividing those things. Here it's about 1. It's 1.02. Here, now we're going to take an absolute value, and so I'm going to actually do absolute value of this, and your textbook does the regular value with the negative, but we would need that absolute value. And then here we get about 13.13. And so actually, as I look at this model, that's going to be significant, that's going to be significant, but definitely that's not. The p-value here is, according to the textbook, is, so p, yeah, these are basically 0 to many decimal places. But the p-value here is 0.88 or 0.89, and the p-value here is about 0.31. And so those slopes are not significant. So how might we handle this? Well, we would, what we want to do is examine removing some of these variables. And if we look at all of these together, again, according to the text, the adjusted R squared is 0.7108. So if we use all of those variables and our data, we get an adjusted R squared of about 71%. So that looks really good. And what we might do is first, since the looking back here, right, our worst thing was the length of the auction. I mean, they had a p-value of 0.89, right? So let's take that out and redo this model with just the condition, the photo, and the wheels. And if we do this, then what we find is that our y is equal to 5.17 times the condition plus 1.12 times the photo, whether it's stock or not, and then plus 7.30 times the wheels. And I just started thinking, I don't know if I got my, yeah, I didn't put the y-intercept in up here. Sorry about that. That was, I don't remember. I'm kind of looking at the text while I do this. I have to go back and look. I'm sorry, I don't remember what that intercept was. We don't really care much about the intercept, so I'll just say intercept. And here, the intercept is 36. Okay, and in this case, we get an adjusted R squared of 0.712. So really not a great improvement. Nothing big there. So, you know, between these two adjusted R-squareds, I would say the two models are fine. But what's nice is, yeah, the two models are fine. I mean, this actually has a tiny bit higher adjusted R-squared, and we got rid of one of the variables. That together is a good thing, because the R-squared itself would have dropped. I don't think the book tells us what the actual R-squared is, and so I don't know how much it might have dropped, but yeah, I could figure that out, I guess. But we aren't worried. We just want to see that, hey, this did go up, and we got rid of one of the variables, and so that's a good thing. And so now I'm kind of running out of room here, but when we look at this again, what we see is that p-value for the photos is still, in this case, our p-value, so I'm going to squeeze it in up here, is 0.27. So we want to get rid of that one as well, the photos, because again, our hypothesis test says, you know, probably that slope is actually 0. And so when we do it again with just two of these, we get 5.58 or $5.58 by having something that's new, plus let's see, and 7.23 times the wheels. And then the y-intercept in this case was 36.7. And here our adjusted R-squared is 0.712 as well. Now this one was actually 7.28 and this one's 7.24. So it went down ever so slightly in the 4th decimal place. And so again, we're explaining about the same amount of variance, but now we're only using two variables, condition and wheels. And so this model here is much better model because we've gotten rid of the bias that we would have put in artificially from the photos and the whatever that other thing was. Let's see, the photos and the duration. And so we've gotten rid of that bias, okay, but we really haven't changed the variance, so that's a good thing. So we've been able to lessen our bias without adding much in the way to our variance, and by looking at the adjusted R-squared. And so what we would want to do is, if we're trying to explain price, I put Y here, but that was really price, wasn't it? If we want to explain price by these various aspects, it could be we're most interested in condition, but a definite confounding variable is wheels. And actually, the confounding variable wheels has a bigger effect on the price per wheel than whether it's a new or old condition toy. And so, you know, that is how we go about using our model to help us determine how we want to look at dependencies for price. So it looks like there's a dependency and a predictive quality of condition and price, and there also appears to be a nice predictive quality of wheels and price. But both variables matter, and so to only look at one, just condition, would mean, well, we had this confounding problem of the wheels, or if we only looked at the wheels, well, we had this confounding problem of the condition, and so we might have been telling an incomplete story that was then also a bit inaccurate. So if we went back up here and said, oh yeah, oh, the condition, you should see an average difference of $10.90 or nearly $11 by doing a new one, and somebody just usually doesn't see that, well, it could be because of the number of wheels, right? That they have something with a lot fewer wheels, and so really, if you account for the number of wheels, and that's what you'll also often see in studies, is they'll say, accounting for socioeconomic status and this and that. Well, if we account for the number of wheels, we see that the condition still matters, okay? It still matters, but it only matters about half as much. It's only around $5.50 instead of $11, okay? So that's why we want to look at more variables. But on the other hand, we don't want needless variables. So in this case, we really want to just look at our prediction and our dependency and so forth with the condition and the number of wheels. We don't want to worry about the photo nor the duration of the auction.